It has a definite size, but it assumes to take the shape of the container. The liquid is in contact with solid here, and that is called angle of contact. So depending on whether it wets or doesn't wet, we define angle of contacts. The liquid behaves as an elastic membrane which goes on contracting and occupying minimum surface area. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my yesterday's session on the chapter Fluids, we understood a very important theorem called Bernoulli's theorem, which told the sum of the pressure energy, kinetic energy, and potential energy per unit mass of an incompressible, of an ideal fluid is always a constant. And we learned the applications of Bernoulli's theorem. For example, it may be the lifting of an aeroplane, working of an atomizer, and so on. In my today's class, we will discuss a very important property called as surface tension of the fluids. Now, we will understand the meaning of surface tension with respect to something called as adhesive forces and cohesive forces. So here we are studying a very special property of fluids, what we call as surface tension. Now, we all know that a liquid that is poured into a container takes the shape of that container. So right in the first class, I have told a liquid doesn't have any shape. It has a definite size, but it assumes to take the shape of the container. Now, the force of attraction that exists between the molecules of different substances. So basically, what is responsible for surface tension to come into picture is the force of attraction between the molecules of different substances. See, for example, when a surface is painted, the paint sticks to the surface because of the force of adhesion. So we say the force of attraction that exists between the molecules of different substances. Adhesion. And the force of attraction that exists between the molecules of the same material, that is what is called as force of cohesion. Coherent, something being same. So understand, students, the force of attraction that exists between the molecules of different substances called force of adhesion, and the force of attraction between the molecules of the same substance is called force of cohesion. Both of them basically responsible for something called surface tension. Now, let us try to understand what actually is surface tension. Surface tension of a liquid is a property of the liquid. Surface tension is the property of the liquid due to which the liquid behaves as an elastic stretched membrane. Very beautiful term. Because of this property, the liquid behaves like an elastic stretched membrane which tries to contract. The membrane tries to contract and occupy minimum surface area. See, very beautiful property. We say surface tension is a property because of which the liquid behaves as an stretched membrane, elastically stretched membrane, which is contracting and trying to occupy minimum possible area. But why does this happen? Why does the liquid behave as an elastic stretched membrane? Why does it contract? Why does it occupy minimum area? That is because of this reason. Suppose this is the surface of the liquid. So this is the liquid filled inside the container. This liquid will always exert tangential force per unit length. Tangential force on the surface of that liquid. There is a tangential force acting on the surface of the liquid. Because of this tangential force, the liquid goes on contracting, occupying minimum area. Therefore, students, surface tension is also called tangential force, force per unit length of the liquid. Because of this tangential force, because of this force per unit length, the liquid behaves as an elastic membrane which goes on contracting and occupying minimum surface area. Therefore, the SI unit of surface tension is Newton per meter. As I told, tangential force, force per unit length of the liquid. So whose SI unit is Newton per meter. Force per unit length. Force is Newton. Length is meter. F by L, Newton per meter. Its dimensional formula is mt minus 2. So remember, physically, surface tension is force per unit length of the liquid. Tangential force acting on the surface of the liquid, which will elastically stretch liquid as a membrane, which is trying to contract and occupy minimum possible area. Now we have a concept called surface energy, students, where we see the molecules on the surface of a liquid, not interior. The molecules on the surface of a liquid have larger potential energy when compared to the molecules deep inside. So the potential energy of the molecules on the surface of the liquid is greater than the potential energy of the molecules inside that liquid. So that, hence, if a molecule has to be moved from within the liquid to the surface, work has to be done. Same molecules, cohesive force. So we are doing work against the cohesive force. As a result, its potential energy increases, and this is what is called surface energy. This is important. Now, something called angle of contact. When a liquid is in contact with a solid, suppose this is the solid and this is the liquid which is in contact with the solid. Listen to this carefully. When a liquid is in contact with a solid, the surface of the liquid will be curved. The surface of the liquid will be curved at the point of contact, where the liquid is in contact with the solid. The surface of the liquid is curved, and at the point of contact, there is some angle defined between the tangent to the liquid and point of solid. And this is called angle of contact. When I draw a tangent to the point where the liquid is in contact with the solid, an angle is defined, and that angle is called angle of contact. As you very clearly see here, in both the cases, there is certain angle defined. The liquid is in contact with solid here, and that is called angle of contact. So what is angle of contact? It is the angle between the tangent and the point where the liquid is in contact with the solid. So if you observe, for liquids which wet the surface, where theta is less than 90 degrees, so for theta less than 90 degrees, or for liquids which do not wet the surface, where theta is greater than 90 degrees, the angle of contact for pure water and clean glass is 0. For mercury and glass is 135 degrees. So depending on whether it wets or doesn't wet, we define angle of contacts. So my students, in this session, we learned what is force of adhesion, force of attraction between different molecules, force of attraction between the same molecules we call force of cohesion, basically responsible for a property called surface tension. What is surface tension? Tangential force or force per unit length of the fluid, which makes fluid as a membrane which is contracting and trying to occupy less area. Force per unit length, Newton per meter square. What was angle of contact? Angle between the tangent and the point where the liquid is in contact with the solid. Very clearly, for pure water and clean glass, it is 0. Mercury and glass, 135 degrees. Pure water and pure silver, 90 degrees. So in my next session, I come up with another property called viscosity. Until then, have a nice time. Thank you.